Hello, it's Alex here, and I want to share my project about hands-on materials in the first grade mathematics classroom with you. So, just a little about me. I'm a first grade teacher in the Central Dauphin School District. This is my 5th year teaching. I'm currently getting my master's degree in education in assessment curriculum and teaching with a STEM concentration. And just to give you a little background about our school year this year, I know we've all had crazy school years. We started the year with hybrid learning, with only half the class coming in at a time. And then we moved to full in-person instruction, which is where we were through the entirety of my project. So I got really lucky with that all the students were there. And now we just moved to virtual learning full time. So, a little bit about my project. I really started with the broad purpose of increasing student engagement during the school day. That was the first thing I wanted to look at before looking at a specific subject. And when I started to think about student engagement, I really narrowed down on studying hands-on manipulatives. It's something we use every day in first grade, no matter what the subject is, whether it's connecting cubes, counters, alphabet letters, little games, little cards for reading. Doing hands-on learning is something that we're always doing in the primary grade, so I thought that would be a really great thing to try to study. And lastly, I whittled down my subject area to math, since we do use a lot of hands-on manipulatives in math. So the goal of this study was really to determine if the use of hands-on materials do increase student engagement during mathematics or not. Which leads me to my research question of how can hands-on learning impact student engagement in a first grade mathematics classroom? So I'm going to quickly share the 5 resources I found about this topic. So the first resource I found by Morgan, Farkas, and Maxuga analyzed the effects of instructional strategies on first grade mathematics. So that was pretty specific to exactly what I wanted to study. And they determined that teachers should utilize a mix of hands-on instruction and teacher-directed instruction to maximize educational benefits for first grade students. So it really didn't say that hands-on manipulatives were better or teacher-directed instruction was better, just that there should be a mix of both. And very similarly, in the Rust study, she studied teachers' best practices and students' achievement in mathematics, and she concluded that the most beneficial environment for students was one where the teacher paired standard instruction with manipulative. So pretty much the same outcome as the first study, that there should be a mix. In the Jacob, Erickson, and Matera and MDRC study, they actually implemented a supplemental small group math program for kindergarten-aged children in New York City. So this was a program in addition to the regular school day, something that kids would go to after school. And the program delivered math instruction in a game-like format with the use of hands-on manipulatives. Students who were involved in the program reported a more positive attitude towards math and also performed better in mathematics. So the hands-on instruction and the game-like format really motivated the students and engaged them. In the Julia and Antoli study, they studied the long-term effects of a STEM-based program. So once again, hands-on investigative learning, and they concluded that a hands-on STEM course creates an environment where students feel interested and engaged. So once again, backing up the idea that students love hands-on, they love to play around and explore. And once again, very similarly to that study, Wright and Jones decided to research the implementation of an innovative curriculum for elementary age students. This framework followed the hands-on learning pedagogy and focused on divergent and convergent thinking principles. The researchers claimed that the use of hands-on materials aided the students in replicating real-world problems in the classroom. So, looking at my own research study, the goal for this project was once again to assess if hands on materials improve student engagement during a math lesson. Now, I did also want to assess if students could or could not perform the specific math skill with hands on manipulatives or not. Engagement was really my focus, but I also did want to check just to make sure, for the benefit of my students, that the hands on materials weren't impeding them in any sort of way from solving the problem. And I did really want to know if they did help the students solve the problem, even though I was really focusing on the engagement piece. So there were 3 different data collection techniques I used to collect data. So the first design I used was to assess if students could perform the skill or not. And this was just a teacher-created checklist. This isn't the exact checklist I used, but it was the easiest way I could put it into Google Slides. So basically, I had all of the students' names right here, and then I just had 1, 2, 3, 4. And the blue columns mean that they did it without with the manipulatives. And the orange column means that they did it without manipulatives. So basically, I gave the students 4 problems. For the first 2 problems, they could use manipulatives, and then I would go and check to see which students could or could not, and every student just got a quick check marks or an X. And the last 2 problems, the students could not use their manipulatives, and I once again just did a quick check around the room. Originally, I had really wanted to have a mixed group. So half of the students were using manipulatives, half of them were not. So I could see how students performed on the same problem. But with first graders, that caused a lot of problems, a lot of, they thought it was unfair that some kids were using tools and others weren't. So just to get those behaviors out of the way, I just had them all doing the same thing. To check for student engagement, I used a student observation tool that I found on Google. The only problem I had with this tool was that it was almost impossible to write comments for every single student. So you just kind of write these little notes quick. So if a student was listening and watching me and they were on task, I would just put an N1 in this box. But if they were off task, if they were disturbing others, I would put an F4. But once again, it was really hard to see all the students at the same time. So I kind of just wrote things that stuck out to me. But I will be honest and say that other behaviors could have easily been missed just because I was teaching at the same time as trying to check all the students. So there were some things that could have been missed. To check for student engagement, I just used my own teacher observations on a piece of paper, a piece of blank paper that I found in my classroom. And I would just quickly jot down the observations that I saw. And then after the lesson, I would go back through and just write some comments and interpretations of what I saw. So my findings were actually correlated with what I had suspected. Not only could the majority of students solve addition problems better with manipulatives, they were more focused and engaged in the lesson when they were using manipulatives. So first, looking at that teacher-created checklist where I just went through to determine if they could solve the problem or not. In the first lesson I did this, students were using colored counters and they used the counting on method. So if I gave them the addition sentence 7 plus 4, they would start with the number 7 and then they would count on 4 more. So 8, 9, 10, 11. So without the colored counters, they answered 20 out of 28 questions correctly, and they got 8 incorrect. That's a total, all of them together. So there was 14 students this time, and they did 2 questions with and 2 questions without. But with the colored counters, they could answer 23 out of 28 questions correctly, and they only got 5 wrong. So not a major difference. But it is small enough. If they were taking a test, that's 3 problems that they would have done better on. And the questions were very similar to each other. And then once again, talking about that teacher-created checklist, for the second lesson, they were solving addition problems using connecting cubes. So without the cubes, 24 out of 30 questions were answered correctly. But when they were allowed to use the connecting cubes, they answered all 30 questions correctly, and there were 0 missed questions from the whole class when they were allowed to use their connecting cubes. And then the last lesson I did with the teacher-created checklist, just to check if they could solve the problem or not, was adding 3 numbers with connecting cubes. This one was a little more difficult for them without the cubes. The class only answered 17 out of 30 questions correctly. They got 13 wrong, so it's pretty close to 50% of them wrong. But with the connecting cubes, they answered 25 questions correctly. So a pretty big jump there. Okay, looking at my second data collection tool, which was that chart, that student engagement observation tool, which looks like this. So when I used that tool, I used that 4 times throughout the lesson, and I really focused on just 4 of those little behaviors that I could jot down. So the behaviors N1 and N3 represented on task behaviors, while F4 and F5 represented off-task behaviors, like disturbing peers or playing. So in the lesson I did, it was just addition with connecting cubes again. Without the manipulatives, these blue and red are these are the on-task behaviors, those N behaviors, and the yellow and the gray are the off-task. So we saw a lot of off-task behaviors when students were not using the manipulatives. But on the next day, doing the same lesson with manipulatives, the connecting cubes to add, we see a lot more on-task behaviors, and the off-task behaviors were severely diminished. So those on-task behaviors were listening and watching and speaking, answering questions, things like that. So a lot more, they did a lot better with the connecting cubes. And in the next 2 lessons, students were making a 10 with colored counters. So they were figuring out friends of 10. If you start with 2, how many do you have to add to get to 10? And then counting on from there. So without the manipulatives, these blue and red, these are the on-task behaviors. So they did a little better here on task without the manipulatives. But when we were able to use the the colored counters, they did even better. And they were much more on task. So it's about 2/3, and then 1/3 of the time they were off task, which is pretty good for a 6-year-old. And then when looking at the results of my own teacher observations, I noticed that many students, especially the low achieving students, really did rely heavily on the manipulatives to help them solve addition problems. They were much more confident. When I gave them a task, they didn't dread it and roll their eyes. They were ready to attack it. They knew what to do with their manipulatives. And when given the choice, students almost always preferred to use manipulatives than not. So if I let them choose if they wanted to use them or solve without them, almost every student chose to use some sort of manipulative every time. So those manipulatives really did increase the motivation for students. And when working with manipulatives, students remained on task and did not need reminded to follow directions and focus on their work as much as they did when they were not using the manipulatives. So in conclusion, after conducting my own research, I can say that hands-on manipulatives in mathematics do increase the engagement of first grade students while they're solving addition problems. So I really wanted to specify that it was addition problems. I don't know if it would work the same way if you were studying another topic, but this is what I found, and my students were studying addition the whole time during this project. These are just a couple of my favorite manipulatives to use. We use connecting cubes a lot. The different colors really work well. They're organized for students, and they kind of get that their building feel. They love Legos, so using anything like that is really motivating for them. We use these colored counters a lot. And something we use a lot that I did not use in this study that my students love are mini erasers. They love anytime they get to use that. That's really motivating for them, and they love to use the mini erasers. So I